Hello everyone, welcome to Big Data Knowledge Hunt. In the today's video, we will be going to see an example of navy bias. As you can see on my screen, I have already shown you I already written the Python code for that in the Jupyter notebook, and today we will be going to see this Python code written in the navy bias. In the previous video, we have already shown what is mean by navy bias. Also, we have shown the Python code for it. What is navy bias? Example for it. Also, we have shown one numerical. Link to that videos will be in the description. You can go through it. Also, I will be provide the playlist for navy bias in the I section. You can go through it. Now today's section we will see a simple navy bias Python code. It is a very small code as you can see here. So I will be explaining in detail. So in the previous video we have shown how the navy bias algorithm works. So in this video we will be seeing how the Python code is written. It is a basic very simple code. The Python code we'll see one by one. So these are the basic header files that are needed to execute the navy bias code. So basically these two are the header file needed for the execution of the data frame, that is the importing the data set or for the execution of the data frames. Next is the this as you can know, as everyone know, this is needed for the splitting the data set. This is the header file needed for the navy bias code, execution of the navy bias code. Gaussian NB is the navy bias theorem which is used, or this is the package which is used to execute the Python code. This is used for the accuracy score, to get the accuracy score of the navy bias algorithm. And these are the plotting libraries if we want to plot something, if we want to plot a graph. So these are the basic header files we'll need to execute the Python code of the navy bias algorithm. Okay, now we will, first thing is we have to import the data set. So to import the data set, this is the data set. So I have imported the data set from the library, and my data set is already present here. As you can see, this is my data set. So the data set consists of three columns, that is glucose, blood pressure and diabetes. So we are predicting the diabetes score based on the glucose on the BP of a patient. So diabetes is our prediction column, and these are our we can see x and y, and this is our predicted column. So now I have printed the 10 rows of the column by using the df.head. So df.head is used to print the column. So I will show you the execution also one by one. After importing the header files, I have printed the first 10 columns of the data set. So as you can see here, the 10 columns are printed. So diabetes is our prediction label. Now here x is our feature and y is our label. So we are going to predict the y based on our x. So x works as the independent label. So we are focusing on the y, that is our diabetics column. So we are focusing on the diabetics column, which is we are providing it as a y. So we are providing y in from the database. We are putting the y diabetics entry into the y. Now we are dividing the data set for training and testing. Now the dividing ratio we are using is, we are providing 0.25, means 25% of data we are using for testing purpose, whereas 75% of data we are using for training. So now the random state ensures the reproducibility, means 42% of data can be reproducible. Now we are using 25% of data for the testing purpose. So now we are using the train and test data. We are dividing the data for training and testing. So we will be using the 25% of data for testing purpose. Here we will be dividing the data for training and testing. Now we are using the model here. So I have written the files. This is the code for the navy bias. So as you can see, there is only 2 lines of code for the navy bias algorithm. So the whole algorithm is incorporated into only 2 lines. So the model will be trained on X train and Y train. So the train data will be trained on, the model will be trained on the training data, which is X train and Y train. These are the training records from the large amount of data. Now we want to predict the model on the testing data. So the testing data is the X test. So we want to predict the model, and this array is the collection of the output. What is this output? This 111, these are the output of the diabetes. So out of the 25% testing data, whatever the entries are there, the output will be either, like here the output is 001. For same for the 25% of testing data, the output is 110. Means if it is 1, then the patient will have the diabetes. If it is 0, then the patient will don't have the diabetes. So this is the output for the 25% of diabetes patient data. So if we want to test the accuracy, the formula is accuracy score is test y and the predicted score into 100. So this is the accuracy score formula, and we get the accuracy 92%. So how we calculate the accuracy, how the accuracy is calculated, what is the precision, what is the recall, already I have explained that also. Link to that video will be also in the description, you can go through it. I hope everyone is clear with the explanation of the simple Python code, how it is executed and how the basic data set is. If you want to execute this code, you can execute it. You can simply prepare a simple data set which consists of 3 columns, that is glucose, BP and diabetics. You can put a random entries in it and you can execute this Python code. It is very simple. You can just write it and execute it. So I hope everyone is clear with the idea how the Navy Bayes algorithm works, because the working is already explained in the previous video. Also the numerical is also explained. You can go through it. So thank you for watching the video, and for more such videos, stay tuned towards the channel. Make sure you subscribe it, and don't forget to follow me on Instagram for more details about the upcoming videos. Thank you everyone.